And this is day number 12 of Advent of Code. We've got about 3 minutes left on this timer. I managed to thankfully finish my E-Fleet on time, so therefore I am ready to go with Advent of Code. I did do, while I was flying a logistics ship, I did also manage to get my stuff set up. So I've got a day 12 file and all that good stuff. And yeah, we'll just see what today's puzzle is. I unfortunately had to log off my ship in a system that is a little bit hostile in order to make it to stream, but stream is slightly more important, and the situation is under control. The baddies were defeated, so all is well. Yeah, I hope people's days are going well, that you all had a good weekend, and I am definitely looking forward to today's puzzle, and we'll see what's in store. Also, I made lasagna for dinner with a partner, and it was amazing. Lasagna is so tasty, especially homemade lasagna. Hi, Eric. How are you doing? But yeah, let me see if I can pull up the fight to show you all what I was just up to. Let's see, there should be some kill mills on here. Oh yeah, there are some kill mills. We killed a bunch of people in the system named Inky in Solitude. And we are currently in the middle of killing a structure, a Asbel, which is a structure used for construction of capital ships in Eve. And yeah, it is going boom pretty much right as we speak, except for I couldn't be around for the explosion because I had to get started with the puzzle right when it started. I know there are definitely some Eve players among us. It was with ricotta. We did not have time to make bechamel, unfortunately. But I did hand grate the Parmesan and mixed Parmesan, ricotta, and a little bit of egg yolk. It's really tasty. Definitely would recommend. All right, let's get this ready to go. Oh, whoa. That's not what I meant to do. There we go. That's more reasonable. Glad I caught that before I started to write contents to a directory. That would not have gone well. For some reason, even though today is normally one of my sleepy brain days, it's actually reasonably fine. Feeling relatively alert. I think I rested enough today and didn't overexert earlier. All right, here we go. This is day 12. Oh, thank goodness! We finally have we finally have a graph traversal. Big caves and small caves. Visit all small caves at most once. Yeah. How many paths are there that visit? Okay. Yep, I understand that. That's reasonable. So this expresses the relationships that exist. Great. All right, so let's do it this way. Okay. Okay, so I know what tools I'm going to need. Parts is going to be strings split s dash exits parts 0 equals parts 1 and vice versa. Okay, so now we also need to keep track of what we've visited. And we also will need a... Don't want to write this logic too many times, so we'll just do it this way. Okay, so the little caves are going to be the ones that that start with lower letters. Okay, something like that should do the trick. Now, okay. So, visit small caves at most once, can visit big caves any number of times, and as soon as... Oh, I see. And then I have to get to the end by definition. Once I reach the end, I am done. And I am allowed to partially visit things as well. Okay, so that's fine. So yeah, actually, I don't need to do this. Okay, so that's fine. All right, so the way that we do this is we're going to record a path as a sequence of strings. And we're going to keep on extending paths until each path reaches the exit. And that's how we're going to do it, I think. That makes the most sense to me. And the idea about what makes a path unique is just the sequence of entries in it. So I'm not going to stress too much about this for now. And I also really hate recursion for these kinds of problems, which is why you do not see me using recursion to do these. Cool. Oh, and on the lasagna, it was a non-traditional meat. It was just ground chicken. Okay. For range. Yeah, because the set of places you can go from a given point may depend upon what's already been visited. So, in fact, let's do... Is it possible for something here to wind up infinitely... Small caves? Okay. Can I wind up infinitely looping? I think this has been carefully constructed so that I cannot infinitely loop. Yeah, okay, let's assume that for now. Technically speaking, if I visit things in a different order, yes, that counts as a separate thing, unfortunately. Okay. Okay. That all makes good sense to me. Now what do we do? Actually, the path that we first start off... Okay. If... if this is the end, then paths plus plus, and we have reached the end. Okay. All right. So, otherwise, we need to generate all neighbors of current node. Make filter for adjacencies that are not yet visited or are big. Create a copy of the current path with the adjacencies added. Create copies, plural. And then push those onto next queue. That seems straightforward enough. I think I can do that. All right. So let's just do this to, whoa, that was not what I meant to do. So let's do that. This is a unique path. So this is implements from a breadth first search non-recursively using a work list. Okay. So in fact, this needs to not be a map from string to string. This needs to be a map from string to, okay, that was the thing that I messed up earlier. All right, and this one's the same thing here. All right, that's much better now. Okay. Includes last if okay. If path visited, oh, is visited, n. So then we are going to continue. Now, next queue, length of path plus 1. Do it now. Copy into path copy. Just make sure that I have this correct. Built-in copy. Yep, that looks fine. Oh, and my cell phone is buzzing my mic. I need to move it further away. Okay. Actually, yep, we're going to do it this way. Okay, so something like that. And then append next queue. Going to need to append n. Or no. Append next queue or path copy n. And then path copy. Okay. I think that should do it, and this will terminate because these will eventually reach the end, one hopes. Let's go ahead and delete the things I'm not using. I'm not using strconv. See what happens. things. Line 22 is visited. Oh, that's a bool. This could be optimized actually. If n is little n, return false. It's always safe to revisit big caves. So this actually can be instantiated with one value, which is start, I think. That should do it. Line 50 is wrong. Oh, I think I need that. Line 54 is wrong. Yep, that's fine. And append. Where is append? Oh. Right. Right. Let's make sure this returns on the simple input first. And if not, then I have an obvious bug. Okay, I have an obvious bug. So let's just check this. So before we do anything else, let's just print out the exits, just to make sure that we have this correct. Okay, so A goes to start, C, B, and end. Yep. B goes to start, A. B goes to start, A, D, and end. Yep. C goes to A. N goes to A, B. Yep. D goes to B. Yep. Okay, that looks good. Okay, so the problem is not in this logic here. Oh, because I forgot to set next queue, that's why. Great. Okay, that should do it. Okay, so this yields 10 paths, that's correct. So now let's run it on my input. 5,228 paths. That's correct, rank 893, not bad. If I hadn't gotten tripped up by that last failure to update the work list, I would have gotten much higher. Okay, part 2, I might have time to visit a single small cave twice. A single small cave can be visited at most twice. Okay, that's reasonable enough. So I can visit exactly one small cave twice. Okay, so what I'm going to do is I'm going to augment the path with the double visited cave. And I think that that should do it. So yeah, we'll do it this way. So we're going to have a something like that should do the trick. Alright, so now we have a modified version of this that works on path with repeat. So a path with repeat is allowed to visit a single node twice. All right, so I think that should do it. The other catch is that if it's already been logged as the repeat, then we need to mark it. Because otherwise, I don't want to visit it 3 times is a thing. So visit the first time, it doesn't get logged as a repeat. When I consider visiting it the second time, I log that as the repeat. And then on the third time, what's going to happen? On the third time, if it's already been visited... Okay, yeah, I see. So, yep. Yep, so that'll work. Okay, so if it's already been picked as a repeat, you can't visit again. If the repeated node has not been set yet, then we can allow it to happen. That's how we need to do it. Okay. So if it does not match, okay, so we're checking things that have been seen before. Repeated node. Okay, got it. I see. I was just complicating my logic here. Yeah, now I understand what I did wrong. Okay. Great. That all looks reasonable to me now. Yep. Okay. Great. So now I can run the work queue again. So now let's do this again. So now we use the augmented path with repeat. So this takes a and that. Okay. Okay, so we have something like this. That still looks fine. Oh, and we cannot revisit start. So now I need a custom just let's just guard against double visiting start, since we know that that one's another special case. Okay. Yep, that all looks fine. That looks fine. The only difference here is path copy. Yep, and then we need path with that is a path with repeat. Visited is path copy, and then I need the repeat, which is, this is called repeated node. I can see how this one might trip someone up, honestly. I can see how someone might get tripped up by this. Okay, so repeat equals item.repeated node. So actually we'll put this up here. So this needs item is visited. So something like that. If not, if visited too many times, continue. If is repeat, then repeat equals n. Okay, that looks fine. Okay, let's try that. Okay. Range P, oh. Range P dot visited, yep. Line 105 is bad. Okay, so fine. I might need to do it to specify this is just going to have to be Q because I can't rename it and change its type. That's fine. Missing type in composite literal. Something like that. Line 112. Oh, because this now needs to range over Q. Yep, that's fine. 5 next item. Oh, that needs to be defined here. And here, this has next item instead. Okay. Let's run it on the simple one, just to check it. So this path has first example and the first example we had 10, and now there are going to be 36, not 63. So I have an error in my logic, which is fine. We'll fix that. So I have visited it too many times. Oh, I see the problem. If is repeat. So let me just make sure is repeat is set true in this exactly this one case. Yep. Then repeated node. Oh. Whoops. Whoops. Yep. So get set to repeated node by default. It has been visited too many times and we cannot consider it. This should never get set. Let me just check this. Okay, something like that, and we're just going to return from the function. Okay, nope, did not hit a this should never happen, so I have some other bug here. Okay, I'll leave that in for the moment until I take it out. Oh, I'm using the wrong is visited clause. Nope, item is visited, not path is visited. That's fine. I am visited if last... Oh. Because we needed to finish here. I have a bug. This needed to have a continue here. I don't know how I got the right answer before, because this should have happened here. Okay, now I get the correct answer here. Okay, yeah. Okay, so now I can take that out. Okay, let's set this running on my input while I save the intermediate, and then let's figure out what I need to do to optimize. Oh, okay, I have an answer. Let's go ahead and paste it in and see what it says. Oh, that's the correct answer. Yay, I did it. Awesome. That is exciting. Ta-da! All right, let's go ahead and clean up this code, and then we can go ahead and wrap up the stream. So today was, it was an algorithmic day, but it was not too challenging. I felt like it was doable. So I didn't need the intermediate input, which is nice. Okay. So let's add some comments here. Is visited finds whether this node has a proposed node has been visited too many times, as well as whether the visit is a repeat visit of a little node. Okay, cool. Thanks, Eric. I appreciate you cheering me on. This is super fun. I definitely was enjoying the puzzle. So the main thing I want to clean up actually is I want to set this to something affirmative. I'm going to change this to may visit. So we're going to swap these because I think that that makes the code a lot more readable. Repeat visit of a little node. Okay, cool. So may visit, so now I need to invert this logic as well. So if it's a big node, now this makes a lot more sense. So this is going to return true here. It's going to return false here because we've already used our repeated node and we're there again. No third visit. Also special cases start, which were never allowed to revisit. Okay, and just for consistency, let's express that way. So we're not allowed to visit. This is okay to visit, but must be flagged as repeat. It's not okay to visit. Already used our repeat on another small cave in this one. All right, and otherwise we can visit successfully. Okay, so may visit. I'm just cleaning up code, Irene's. So if we're not allowed to visit, that's fine. So now may visit. So let's just clean this up. Okay. That seems simple enough. I'm going to make a utility function that returns a clone of a path because I really hate having duplicated this logic. So what we're going to do is do this and do this as well. That way that's a lot simpler. Okay, so something like that. Did I call it extend or clone? I called it extend. Yeah, that's correct. Okay. So now this could more easily be expressed as a ternary. Okay, so now I have taken care of that. This logic is substantively the same, and this is now self-explanatory. Okay, cool. That feels fine. Let's go ahead and run it. Oh, does Golang not have ternary? Arg. Fine. Fine, we will do it this way. That's okay. If is repeat, then next IM repeated node equals n. Okay. Oh. All right, and I presume Eric has some kind of faster solution than this, but it runs, within a couple of seconds, which I consider to be good enough. Yep, so it works on my genuine input. It works on the short input. Okay. And this exits is expressing a different construct, so that's fine. Do I ever use isLittle? Yeah, I use isLittle in both of these places, but that's okay. Guess in theory I could coalesce this logic and just set repeated node to something that doesn't exist. And then I could merge the two sets of logic and basically claim that, yeah. Actually, now that I think about this, let's go ahead and combine this here. I'm going to commit it first. But I think I can simplify this even further. So I'm not even going to bother committing it. I'm just going to stage it. Because what I think I can do here is yeah, so I think basically what I can do is this. Has is equal to 0. And then instead of printing it, return paths. This is always nice to just tidy up and delete a bunch of code. This basically will do the trick. Yeah, I think this will work. Line 93 is wrong. What to do? Oh, I just didn't do that. Okay. Oh, and this takes a path with repeat instead. Where is Q? Oh, this is just Q. Yep. Oh, and that needs exits as well. Oh, I see. Okay, so I think something like that should do the trick. Yep, that worked perfectly. And let's run it on my real input. Yep, that worked fine. Okay. Let's see what else I can clean up in here. So now I don't need this may visit. And this isLittle here just can be collapsed since it's only used this in this one place. If cave if it's an A through Z. Okay, So big K's may always be visited. Okay. Yep, that looks fine. And now I don't need this path class either. This is just like so. Oh wait, no, I do. I do need that. Because otherwise I can't do that. Okay. Okay. Extend copies the current path to not share the array. What is it? Slice appends next node. Okay, that seems fine. Yep. May visits logic is now clear. Now we've got a main function that does the parsing and then executes the search twice. Now this can go up here. So search performs a breadth first search recursively using a work list to identify the number of unique paths can be traversed. Paths end if they reach end. And paths are only extended to reachable nodes. Okay. Counted. Work. And put onto work list for their neighboring reachable nodes. All right, I think that seems to do the trick. Technically, I don't need to do this. Technically, I can do this these days. It's considered, I think, slightly more idiomatic to, at this point, define to define go arrays just as the null element, knowing that they'll automatically get appended when they get append. Class that has reached the end. Right. Yeah, I like this code actually rather a lot. I think it's quite well comprehensible. Or visit another node second time. Okay. Yeah, I think this is now reasonably documented, so let's go ahead and format it and push it. After making sure I didn't break it again, of course, but, you know. Yep, Bootstar's completed, just, you know, I like making sure that my code is tidy because it's an educational resource first and foremost. It is, there we go, I knew I introduced a bug. Oh, this is just P and P, or N. Okay. Yep. That works fine. How long does this take? Oh, yeah, that's fine, especially given that this is like a super underpowered machine. Guess the other thing that I could technically do here is I could, if I really wanted to, I could parallelize this. But on the other hand, I kind of don't want to bother to do that. That feels like a giant pain. Although, if I parallelized it, I could make this into a honeycomb example. Ooh, I kind of like that. Let's do that. That seems like a lot of fun. So yeah, and it's only going to generate well, I'll probably only run it on the basic example, but this will only generate 36 trace spans. That's not too bad. Or more like 100 trace spans. Let's see. So let's push this first. All right, so now you can go ahead and see it on github.com/Liz the Gray. So I'll paste this here. And yeah, today's the puzzle where I feel like a lot of the people that I might ordinarily raid are probably going to be yeah, looks like it's just Anthony. I'm happy to be the last person coding today. That's fine. Let's see. There we go. So yeah. Okay, let's do this. So let's go ahead and pull up my my open telemetry example. And we're going to need to grab some boilerplate. Okay, so the boilerplate here is just this. Okay, yep, that looks fine. Okay, let's just hard code this. We don't need a standard out exporter. So I don't need the standard out exporter. We can drop the standard out exporter. Cool. All right. So let's go ahead and fetch a bunch of this stuff. So now in here, we're going to import the tracing module. So parse flags, and then what do I need in here? I need to just run initialize tracing. Okay. And does that return to me a context? Returns to me an OTLP exporter. So what do I do with the exporter? Okay. So I need to do this, something like this. Okay. Great. So now I should be able to go ahead and make a new trace span. To cover each individual call to search. Okay. So now we're going to define a context. and this is going to be a search. And let's go ahead and put in some attributes too. So what I'll want to do is to set attributes. And let's do just print the status of exits just to see what that looks like. Something like that should do the trick. And then let us, inside of here, let's track our iterations, because that seems like that'll be fun. So okay. So now we should have a now we have an iteration, and each iteration that's generated is going to have a, let's call this Q length, and let's put in length of Q. And let's also track the number of routes identified. So let's call it paths so far. Okay, so I think something like that could be fun. Except for we're overwriting what the span means here. In this case, we need to make sure to not overwrite the context. In fact, I don't actually use this context here, so we can get rid of it for now. All right, so let's go ahead and feed in a Honeycomb API key and see what we get. We get a lot of syntax errors is what we get, but that's fine. Oh, that's because I don't have tracer installed. Where is the tracer installed? Ah. So I need over here, go open telemetry io/otel. Okay. Line 98's wrong. What am I missing? Oh, I have too few parentheses. Similarly, over here I have too few parentheses, and over here I have too few parentheses. Okay, easy enough. Okay. All right, so we've now tidied up our go.mod. So let's see what happens here. And yes, you can definitely start from the end, I think. That's a totally valid thing to kind of meet in the middle. I just chose not to do it because the data set was small enough. I was prepared to do it, but I didn't have to do it. Oh, that's fine. Where is error? Oh, there's nothing that can possibly error, so that's fine. Okay. Did I import and not use trace? Oh, this is trace dot. Oh, I need context. And now paths search needs a context.background. Okay. And I need to import go OpenTelemetry.io, go attribute. Okay. So that yielded, you know, results. Results are fine. But what I actually need to do now is I need to actually set these environment variables. So I'm going to go off screen really quickly and do that. So give me a second. Just going to put it on my face while I do this. Just give me one moment. And we'll get an API key in here. And actually, as soon as I make sure that this is a API key that is write only, at that point, I have no problems with showing it on screen. I just need to, let's see, I need got a team called Liz Test. It's over here. So I'm going to pop this. Oh wait, you can't see my screen. Great. That's actually what I want because I need to create a new API key that is called write only and that only has permission to create data sets and send events. Okay, and that's exported, so I can close that. All right, so I think that should do the trick. And now I need to also set the dataset name. So it's going to be Honeycomb dataset. Let's call it admin of code. Yeah, I flashed the API key on the screen. I don't care. All right, so now if I go to ui.honeycomb.io, I should see in a moment a data set called admin of code. If I don't, then I have a bug. Honeycomb API key, Honeycomb dataset. Where did we go wrong here? Okay, this seems to be fine. That's got the latest up-to-date stuff. It's not immediately returning fatal. And we are deferring this call, so this should work fine. Defer span end, defer span end. Yeah. That looks okay. I may need to turn on the OpenTelemetry debug code. Your code runs in 0.3 seconds without optimizations. Oh, I bet it's because you're not needing to reconstruct. Alright, that is very bizarre. Why? Let me take this back away for a second and debug my API key off screen. So this API key is set. Yep, I do have a Honeycomb API key set, and it matches. Huh, that's really interesting. And yet the data set is not appearing. Okay, well, when in doubt, we can turn on the extra OpenTelemetry debugging. So I guess the first thing to do is to put this back in and see whether we get traces if I do try that. Okay, yes, we do get traces that are generated here. So the problem is in my Honeycomb upload path as a result. Wondering whether I might be exiting too fast. Why don't I go ahead and pull this back out. And let's synchronously call this. It's not a recommended practice, but hey, it'll work. Aha. Okay, so the problem was that my main function is exiting too quickly, and even though I told the even though I told my exporter to stop, I didn't tell everything else to flush. That's my problem. Okay, so but now I can visualize does not exist. Yep, so I can see that it's run twice, that my search is run twice, and I can see the number of iterations that have happened, which is kind of nice. That's really interesting, though. Why is it that it thinks that all of them have started at about the same time? You would think that each iteration would start fresh. That's fascinating. So I've probably got an instrumentation bug. Let's have a look at this attempt. Yeah, it's doing the same thing. Okay, so I can work with this. So let's do two things. The first thing that I need to do is I need to, in addition to deferring, okay, so I can use a batcher, but the problem is this needs to also return. My tracer provider needs to shut down, I believe. Open-telemetry, open-telemetry, go. Believe that when I call the tracer provider, I do need to shut it down. Where is my tracer provider? So the tracer provider provides tracers. Is there a... Oh no, because this needs to go, this is in the SDK. in the SDK, in the trace package, so I need to find the shutdown method here. Okay. Yeah, so this needs to... I think I can... Let's do this. Let's see whether that works. Oh, and this needs to return a... This new tracer provider. Do we talk about shutdown here? No, we don't talk about shutdown here. We really need to fix the docs. That is a little annoying. There we go. SDK trace provider. Here we go. Yeah. Okay. So it's just a trace dot and a tracer provider is a struct, so it's going to return a struct. Okay. Oh, and this is a multiple return type. And that wants the context. That's fine. Okay, so now this should have actually shut this down properly. So now we can go looking in here and verify that we see a trace that literally just came in. Oh yeah, there it is. Okay, so the problem is just that my initialization code was bad. So if I zoom into this window and I have a look here. Yep, okay. So now, why is it that each iteration... Oh, because this defer is wrong. This defer only executes when the entire function finishes. Whereas that's not true. I need to explicitly end the span here. Okay. Now my instrumentation is correct. So now, let's run it on my real input and show you all what that looks like. So now I've got something here with loads of spans, and this one you can see took, yeah, there we go. That's the stuff. Look at that. Look at this. Cool. So you can see I ran a bunch of very fast iterations, and then they started getting really slow, right? From, in fact, let's show you the queue length. Right, so you can see that the queue starts off pretty small and then it gets huge. But then towards the end, it actually collapses back down as many of these don't generate very many children and they just report success and move on. So I can also show you here paths so far. So you can see that initially we're iterating, we're not finding anything. And then we find like a bunch of the short paths that lead directly to the destination. And then after that, we fill in the rest of them. Cool. That's really awesome. Okay. Oh, I'm excited that I've done this kind of one time to create the infrastructure for being able to send traces, because now I know how to, I know how to do it. And now I also know that I need to fix up my example code for when I get back into the office on Monday. So now let's diff it. So now you can see what I've had to add in order to instantiate this. Yeah, that is pretty great. Oops, I did it again. It's fine. Yeah, it only takes 3 seconds. It's not too bad. Add tracing to Honeycomb. All right, and yeah, if you found that somewhat interesting, please do check out my employer, although I am currently only somewhat on the clock, seeing as it is a weekend, and I am doing admin code in my spare time, but also, like, I like it when people get to use the stuff that I work on every day when I'm during the week. So, cool. Awesome. Let's go ahead and call it there, and I will see you all tomorrow evening. Cheers.